Alright, hello everybody. I was streaming before, and then I accidentally showed the actual quiz, so I had to pull it down. I'm waiting for the option to show up to trim. You can also hear there's a lot of noise in the background, unexpected guests. So there's actually a guest for the first half of the live stream thing. If I can remove the quiz, then I'll put it back up. We shall see. So, what I'm doing is all my students, basically, they need help for their quiz and their test. So I help them.
Can I have it now?
Come here, Benny.
I need it.
Here.
I need it.
Here, go this way.
I need it.
Take it downstairs with you. Take it downstairs so Benny doesn't jump on you. Come here, Ben. So, yeah, I got some guests. Be able to summarize the process of replication, blah, blah, blah. Alright, we'll go through this first, very quickly. She's getting yelled at because she was squeezing the toy while I'm doing it. So, hold on one second. If you want, I'll shut the door and then it's not a big deal. It's up to you. What do you think? Alright. Okay, where was I? So, replication. We're making DNA. This is transcription. Let me pull up replication real quick. Shush, Calvin. Shush. Easy. Easy. You're barking right in the microphone. Hurt everybody's ears.
Hello.
Hello. Want to say hi to everybody?
Hello.
Did you hear that, guys? You just got a hello. So, right here we got DNA. And in DNA replication, first you're going to split DNA. You've got the enzyme named helicase that breaks down the helix. And you've also got an enzyme DNA polymerase that reads and matches bases. So for period 3 and 4, make sure that you guys make a note of the fact that... Welcome back! Make sure you make a note that one of these is put together in order. The other one is not, so you end up with a big gap right there, called an Okazaki fragment. And it has to be put together with an enzyme called DNA ligase. So, helicase, polymerase, ligase, there's your enzymes. That's DNA replication. So now, one more time, transcription. I'm going over it real quick. Where is it? Where is it? Transcription. There we go. Secret of life. Start with DNA. Helicase splits it, same as before, but now RNA polymerase jumps in, and you're matching one base at a time. One major difference is we're only making one strand this time, and it's of RNA. You'll notice there's nothing up here. Another difference, we're pairing A with U instead of A with T. So that's transcription in a nutshell. Is helicase splits it, and then RNA polymerase will make one RNA strand instead of two DNA strands. Hey, get over here. No barking. All right, let me put the dog downstairs real quick, and then I'm gonna go to the next question. Is that okay? I'm gonna shut the door with Benny just so he doesn't keep barking at you guys, and then I'll be out in like 10 minutes. Come on, Benny. Ugh. All right. Next. Okay, so we just did that one, right? We just compared both of them. How could heat or pH affect replication and transcription? Why? They both have enzymes. Those enzymes are crucial for the process. For example, you need that polymerase to read and match bases. If you had too much heat, well, enzymes denature, which means they wouldn't be able to bind to DNA, and they wouldn't be able to do their job. Chargaff. A with T, C with G. 3 parts of a nucleotide. I can't draw here, obviously, but phosphate is a round, usually. I just draw a round shape. Sugar, I do a pentagon, 5-sided figure, pentagon, okay? And then base, I usually just draw like 2 lines with a question mark because, could be A, T, C, or G. So those are the 3 parts. Now, as for drawing 3 nucleotides paired together, if you have a question about that, ask me in class tomorrow. But essentially, you would draw a circle, and then over here, pentagon, and then you go another circle, and then another pentagon, and you can keep doing that, circle, pentagon, over and over and over again. Actually, now that I think about it, let me show you. I think I have a picture of that. Picture. We'll go to this one. This one works. I'm looking for it. Maybe I don't have the picture in here. I probably did. Shush, 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 shush. Ben, get over here. No barking. No barking. It's a madhouse here, folks. A madhouse, I say. Alright, this one. There we go. Okay, so phosphate, sugar. You see how they connect? And then, horizontally, you can connect 2 bases together. And then you just do another sugar with another phosphate. And there you go. That's how you could connect 3 of them. 2 vertically, and then 2 horizontally. Bam! Just like that. Benny agrees. Oh my god, let me make sure I'm actually live streaming. If I was doing all this and not live streaming the whole time, that would really stink. Videos. Oh my god. How the heck do I find... Oh, wait, maybe this is here. Yes! Review, public. Okay, how do I go to this video? I want to make sure it's actually going. View on YouTube. Yeah, thank you. Yes! Okay, good. I hear my voice. It's been live streaming. Excellent. That would really stink. I went over all that, and it didn't record all of it. Get over here. No. No barking. Son of a gun. Deoxyribonucleic acid, A, T, C, and G, adenine, thymine, cytosine, guanine. What's a gene? Small section of DNA that's used to make a protein. Monomer of a protein, amino acid. Monomer of nucleic acid, nucleotide. tRNA's main job, it carries amino acids. You could also say it matches mRNA bases, but the main job is actually the carrying of amino acids. So definitely go with that. That's the main job. All this stuff, we'll just do a couple. CCC. mRNA. When you're using this table, this codon chart, you are always using mRNA. Triple C, pro. You can find it right here. Here's your C. Triple C. And it goes with amino acid. Pro. Imagine the AGA is mutated to AGT. Now what will the amino acid be? AGA. Okay, so this is a mutation. And we have a T, which means we are working with DNA. Okay? That means that you have to take this AGT and turn it into mRNA. So A goes with U, G goes with C, T goes with A. UCA would be this right here. It would be serine, S-E-R. Okay. Oh, I think I skipped this one, but that's okay. I think you guys get the point of how to use that codon chart. You seem to get it in class. AUG, it's the start codon. You don't start translation and putting together amino acids until you've got an AUG. Okay. Make sure you know like valine right here. Val. There's 1, 2, 3, 4 possibilities. So different amino acids usually have more than one possibility. Just make sure you recognize that. Point mutations. Substitution, where you replace one base with another. Insertion, you add one single base. Deletion, you get rid of one single base. Chromosome mutations. Inversion, translocation. You could insert a giant chunk of DNA or delete a giant chunk of DNA. So there's a difference between a chromosome mutation, a chromosome deletion, where it's a big chunk of DNA, versus point mutation is just the one base. How can a mutation be good, and how can it be bad? Good if the mutation gives you a trait that helps you survive better, like bigger wings that help you fly faster. Bad if it gives you a trait that hinders your survival, like bad eyesight or genetic disease. So that's it. Went over the whole review sheet real quick. And let me see the other review sheet real quick. I think it's all basically the same sort of stuff. A little bit is taken out depending on, this was for period 3 and 4. So things like knowing the assembly of both strands. You don't have to know if you're not in my period 3 or 4. Drawing all the nucleotides like this, you don't have to know if you're in my period 3 or 4, unless you're in period 3 or 4. You probably won't have to go crazy in depth about comparing and contrasting unless you're in period 3 and 4. So a couple differences like that. And tRNA. Period 3 and 4 have to know about tRNA and stop codon and what that means. My other classes, you probably won't have to worry about that quite as much, or really at all. You won't have to worry about tRNA. So you'll see down here, no tRNA. So yeah, a couple differences, a couple small differences. And that's it. If there's no questions, I don't think there are, then I will end it here. You could always leave a comment below, and hopefully it will notify me, and then I could take questions and all that stuff. Hey, and if you want to watch the Fox News live stream today and hear a bunch of people jabbering at each other, uselessly probably, then you could, I guess, click that if it's there. I have no idea who that person is or what that is, and no desire to click anyway. So that's it. Take care, everybody. My phone's ringing. Goodbye.